All right, so in this problem here, I'm going to skip quickly through number 3a and b, and you can see that we have our vertex here at 1, 5, and 3, 13 is on the graph. But what I really want to talk about is c, d, and e. Okay, and so it undergoes a reflection over the y-axis, then a horizontal translation 3 to the right, and a vertical stretch by 2. So if we go step by step, I know at this point 1, 5 will reflect it over the y-axis. It means it will end up over here at negative 1, 5. And 3, 13 will become over here to negative 3, 13. When I then take it and translate it to the right 3 units, and this is going to go over 1, 2, 3 to here to 0, 13. And negative 1, 5 will go over 1, 2, 3 to 2, comma 5. And then when a vertical stretch of scale factor 2 means the y value gets multiplied by 2. So now I'm going to go 0 to 26 times 2. So I'm way up here at 0, 26. And 2, 5 will multiply times 2. And I'll go up here to 2, comma 10. And so my graph ends up being like this. And based upon that, I can find the equation. I know that y is equal to, I'm not sure about the horizontal stretch or vertical stretch altogether, but I do know it's going to be x minus 2 squared plus 10 because of the vertex. And if I want to find what a is, I use this point here, so 26 is equal to a x 0 minus 2 squared plus 10, which will be 16 is equal to negative 2 squared is 4a, and so a is 4. And so I get y is equal to 4x minus 2 squared plus 10. Okay, and that's using the idea of the transformations, keeping track of the points, and then building the equation from our transformations. That is how we could do C part. Now E part says to verify by transforming the equation. Well, if we consider that, I want to pull this down here so I can see it a little bit better. So in total we're going to do 3 methods. The graphing was the first one, and this is the second method. And I actually think this is probably the best method algebraically to do. So what we're going to do is when we have the scenario, I know I'm going to reflect over the y-axis. So if I think about this point here is going to go over to here. And so my xy will change, this x will become negative x, y. And then I'm going to translate to the right 3 units. So I know that my xy will actually transform into x plus 3y, because it's going to go to the right 3 units, because this point here would shift over to the right. And then I'm going to have a vertical stretch by a factor of 2, which is affecting the y value, which means this will become twice as big. And so if x and y are my original points, I'm going to call u is my image point of x. And right now they're not equal. But if I take it, and if I do this in the order, if I take my x and I first reflect it by multiplying by negative, and then I add 3 to it, that is what the new image point will be. Now, if this would have been the other way around, I would have had parentheses around here and so on. But because it's negative first and then I'm adding 3 in that order, I keep track of my order of operations. These ones are what's done to the x value. Similarly, my image point for y, which we'll call v, is not equal yet to y. I'm going to actually take y and multiply it by 2. And so now I'm going to do some algebra on here. I'm going to go u minus 3 is equal to negative x. And so x is equal to negative u plus 3. And similarly, y will be 1/2 of v. And so I will take y and substitute it in for y. I'm going to substitute it in. So it's going to, my equation will be 1/2 v is equal to 2. My x is negative u plus 3 minus 1 squared plus 5. And so then if I just simplify this, I get negative u plus 2 squared plus 5. And if I multiply by 2 both sides of the equation by 2, I end up with v, which is 4 minus u plus 2 squared plus 10. Now, I recognize that this is not the same equation as the previous one. So what I can do, I know v is actually y, and 4. I'm going to factor out a negative from there, which changes the signs of the inside. And then when I take the negative out of the parentheses, I square it, it becomes positive. So y is equal to 4x, because u is actually x minus 2 squared, plus 10. And so using this idea here of the transformations of changing u and v, you deal with the x values and you deal with the y values separately, and you transform the coordinates and you do a substitution. That's the second method. And then the third method, and so I know I have the initial equation, which I'll redefine as f of x is equal to 2x minus 1 squared plus 5. And then the first thing I'm going to do is I'm going to do a reflection. And when I do a reflection over the y-axis, that means I'm going to make this function here. I'm going to reflect f of x over the y-axis. Then I'm going to translate my function. I'm going to translate r. I'm going to translate r to the right 3. So I'm going to take it and I'm going to shift it to the right, so it's opposite sign 3. And then I'm going to take a vertical stretch. I'm going to take my t function, and if the vertical stretch by a scale factor of 2, I'm going to multiply t of x times 2. And now I'm just going to go and build my function overall. So I can then say r of x is going to be 2, plug my negative in, negative x minus 1 squared plus 5. And then r of x, to find t of x, I take x minus 3 and I plug it into r, which will be 2 minus x minus 3 minus 1 squared plus 5, which I simplify that to 2 minus x plus 3 minus 1 plus 3 minus 1 is 2 squared plus 5. And then finally, to find v of x, my final one, I multiply t of x times 2. Everything gets multiplied times 2, each term. And so when I do that, I end up with 4 minus x plus 2 squared plus 10. Now, I recognize that that is not quite the same as what I had up here. Okay, so if I think about this, I'm going to pull out inside the parentheses negative out, and I get x minus 2 squared plus 10. And now if I square this negative 1, it becomes x minus 2 squared plus 10. And so whether I do it with transformations, or if I do it by graphically, by building the function from the by following the points, I end up with the same function at the end.